Okay, so here we have a sequences question, clearly, a sequence of numbers, A1, A2, A3. I'll just put a couple of bullet points on the side before we solve this question. So sequences could be defined either directly or recursively. And the question we're looking at here is going to be an example of a recursive definition. We'll come back to that. The sequence itself could be arithmetic or geometric or neither. And we'll see soon that this one actually turns out to be neither. It's neither arithmetic nor geometric. It's something else. We have formula for arithmetic and geometric, but because our sequence won't be of that type, we'll see we've not got any special formulae that we can use. Okay, so let's come back to the question. We've got a sequence where we are told the very first value is 3, and then we've got this recursive definition, which is telling us how to calculate the next term given the current term. On your calculator, you'll probably find it's easier to use the answer button, but we know that A1 equals 3, and to get the next term, to figure out A2, we have to substitute A1 into the right-hand side of that formula. So on the top, it will be 3 minus 3, and on the bottom, it will be 3 minus 2, and that turns out to be 0. Okay, so the first term is 3, the second term is 0. If you type that in with your answer button, you could just press equals, equals, equals. The next term, if you substitute 0 in, you should get 1.5. And then you substitute that in to get the next term, A4, that should turn out to be 3, which you might notice is the same as A1. So it shouldn't be a surprise then that when we put that in, we get the 0 again. Everything starts to repeat. This is actually a periodic sequence. We write it down, we've got 3, 0, 1.5. And then that repeats 3, 0, 1.5, and so on forever. Okay, so now we understand the sequence. So it's been defined recursively. It's not arithmetic, it's not geometric, but it is periodic. Okay, we haven't actually solved the question yet. So part A, find, remember this symbol means the sum of, everything from the first term, because it says r equals 1 at the bottom, everything from the first term, up to and including the 100th term. So there's no formula we can use, we just need to use our own thinking here. We need to add up all of this sequence from the first term up to the 100th term. So the key is to think in blocks, because we've got this repeating pattern, 3, 0, 1.5. There's 3 numbers in that, so we can, if we have 33 blocks, that would cover 99 terms of this sequence, and the next number would be a 3 again, and that would be the 100th term. So this question is asking us to add up all of those terms. So we've got 33 blocks which contain 3, 0, 1.5, and we've got that extra 3 on the end. So we've got 33 blocks where each block, 3 plus 0 plus 1.5, that's a total of 4.5 in each block, and we've got 33 of those. And we've got 3 to add on the end, and that gives us a total of 151.5. So that's our answer to part A. Okay, we'll scroll down slightly. Part B is asking us for another sum. It's asking us for the sum to 100, the first 100 terms, we've just found that, plus the sum of the first 99 terms. Well, that's going to be very similar, it just won't need that extra 3 on the end that we have been added up 100 times. So for part B, the first part, the sum of the 100 terms is 151.5. And the 99 terms, well, it's 151.5 minus that final 3 that we said we don't need anymore. And that gives you a total of 300 for that sum.